Hello everybody, welcome back. In this video we're going to discuss scatter plots, correlation, and causation. Now we look at this chart here, we have different types of correlation. As you can see on the left here, positive correlation, notice all the data is trending in an upward direction. But then we get to 0 here, no correlation. These numbers down here at the bottom represent the correlation coefficients. The closer you are to positive 1, the more the data lines up into a straight line. Notice here on high positive correlation 0.8, close to 0.1, close to 1 but not exactly, it's a little more scattered. In 0.3 it's more scattered, but still we can tell it's upward. If there's a 0 correlation coefficient, no correlation at all, then we get into the negatives. Notice all this data trending down. And the closer you get to -1 for a correlation coefficient, the closer the data looks like a straight line. Alright, now let's talk about causation, correlation and causation. Okay, real quick here. Two different sets of data, two different items that you're comparing and plotting on an XY plane can be thought to be correlated, and they can always be shown by the types of dispersal of the scatter plot. But the question comes up of whether does one cause the other, and it just depends on the problem. You have to think about, is one the cause of the other? And that's why we say causation. And so I got 3 examples to talk about here, and the answer will either be correlation does imply causation, meaning one causes the other, or correlation does not imply causation. Okay. So let's look at this first one here. Correlation and causation, the number of loaves of bread and the amount of flour used. Okay, so in this, correlation does or does not imply causation. Well, think about the situation here. We make a certain number of loaves of bread and we use a certain amount of flour to make that. The amount of the number of loaves you make does depend on the amount of flour. So whatever that correlation is, one does cause the other. So I think in this case we could say correlation does imply causation, because we need the flour to make the bread, so the amount of flour used, will have less flour but we'll have more loaves of bread. One does cause the other in this case. Let's look at another example here. The number of mailboxes and the number of firefighters in the city. Okay, so someone could take the number of mailboxes and get that data, and then also the number of firefighters, and plot that on a scatter plot. There may be a correlation, but it would probably be strictly coincidental. When you talk about firefighters and what they do and what they use, there's really no relation at all to mailboxes. So this one would say correlation does not imply causation. Alright, let's look at another one here. The time spent exercising and the number of calories burned. We think about those two things. When you exercise, your body does burn calories, and it burns more than if you're just resting. There is a connection between your exercising and your calories burned. In this case, correlation does imply causation. So in this video we're just looking at the different types of correlation and just a few examples of whether correlation implies causation. Hope this helped. Thank you for watching.